Hi guys, and today I figured out how these rotary encoders work. So today I'll be showing you how to code what I've just shown you. These are the KY-040 Rotary Encoders, and you can pick these up all over the place. They're very useful, inexpensive, easy to get hold of, and depending on how long you're willing to wait for them, here you can get one for 34 pence. But if you want them very soon, then Amazon have 8 of them for £11, so that's just over £1 each. They're really useful. For example, if you're doing a menu screen, then you can adjust the rotary encoder to scroll, and you can press the rotary encoder because there's a button to select. Also, maybe you're dialing numbers, so if you're doing a clock, you might want to be selecting the time. So you've got real control because they click, so you can get the exact value that you want, and also you can scroll them really fast to get a really wider range. And the ones that I've coded are pretty accurate. If you want to get started right now, then the code is on GitHub for you to use. You might just want to put your pin numbers in and you're ready to go. And at the end of this video, I do show you how to use the code that I've put on GitHub. But in less than half an hour, we do go through so much. I start off with a simple LED circuit, no code involved, to figure out how these guys work. Then we do some basic code to delve a little bit deeper into what's going on. And I must say, on a personal level, I did not expect the results we got. I thought one click we'd get a certain code, then we'd get a different code, another click, and then it would sort of be a repeating pattern. But it was so unexpected, the results we got. We then code them up, we put it into a class so other people can use it. There's binary shifts in there, interrupt requests, and we also show you how to use the class that we make. So there's so much in this video. One thing though, we did think we could use rotary encoders for Pico Pong. There's a video on that, but not a good idea. It's absolutely rubbish. We used potentiometers instead. But if you wanted to do a menu screen with potentiometers, then you'd have to connect up a button, and you can't get the exact values because they don't click. It's not as good. Stick with the rotary encoders. We go through a lot in this video, so grab yourself a cup of tea, a biscuit. I'll still be here. And let's get going. I'm about to show you me earlier connecting up the simple LED circuit. Let's go. Here I have a rotary encoder. Let's figure out how it works. We have a circuit set up here on a breadboard. If you don't know how a breadboard works, we've got a really good video explaining in detail how they work, but very briefly, each of these row of holes are all connected. So we have 3 LEDs and all of their positive legs are all connected together. So if we put power from this battery pack here into this hole here, I'll go through the resistor because we want to protect our LEDs, up this wire and into the positive legs of these 3 LEDs. If we connect ground from our battery pack to this leg of this LED, the blue one will light up, this one, the orange one will light up, and this one, the green will light up. If we come back to our rotary encoder, you can see it has 3 resistors on the back, and on the other side we have 5 pins here, and they're labelled the ground, 2 resistors on the back, and on the other side we have 5 pins here, and they're labelled the ground, plus the positive, SW, the switch, DT, and CLK. To put our rotary encoder into our breadboard and align it so that the positive pin here aligns with the positive power. Now we can connect our ground to the ground pin, you can see here. And now let's connect the switch pin, which is this middle pin just here, to the negative leg of this green LED. Now when we press this down, hopefully the LED lights. Our next pin is second of the edge, which is DT. We're going to connect that to the middle LED, which is the orange one. Finally, we have our last one, which is the CLK. I'm going to connect that to the negative leg of the blue LED. When we push the button, the green LED still lights up, but if we just do one notch, one turn, a lot has happened. We'll do another one. Both the blue and the red LED have lit up. If we do that slower and turn this in a clockwise direction, the blue one lights up first, and then the red, and then nothing. Blue, red, nothing. Blue, red, nothing. If we go anti-clockwise or counterclockwise, which is the other way, red, blue, and then nothing. Red, blue, and then nothing. Our rotary encoder here is sort of clicked when you adjust it. I'm not sure if you can see. So there's sort of like little grooves that it likes to fall into. little segments. So one full rotation is about 20 of these little clicks and grooves that it likes to fall into. With no code, we've done a bit of hacking with some LEDs to figure out roughly what's going on. Now I've hooked a Rotary Encoder up to a Raspberry Pi Pico and done some MicroPython code to decipher what's going on in a little bit more detail. Here's the code. So here we're just importing the things that we need. Line 5 and 6 are going to be the GPIO pins that are on our Raspberry Pi Pico. So here we're setting up those pins. So we have the pin number, which is DT, and which is 0, and then we're setting that pin as an input pin. And we've put this in a variable called DT pin. The same thing here, but we're just setting up CLK pin. So the pin number is going to be CLK, which is 1, and then we're just putting that in a variable called CLK pin. On our LED circuits, the orange LED was connected to the DT pin and the blue LED was connected to the CLK pin. So in our code, DT pin represents the orange LED and CLK pin represents the blue LED. We'll come back to line 11 and 12 and line 14 and 15, but here we're just printing the values of DT pin first and then CLK pin, which will be a 1 or a 0. 1 just means that the pin is on, 0 just means it's off, so 1 can also be called high, 0 can be called low. And then finally we just have an infinite loop, so this is just so that our program never ends. So line 14 we have an interrupt request, which is this IRQ, and this just does something when something else happens. So the program stops what it's doing and does something else when a specific event occurs. So what is that event going to be? Well, that's going to be if our pin is a falling edge, which means that it's going from a 1 to a 0. This line here just means an or a rising edge from a 0 to a 1. So it'll be listening out for our pin to change, and then when it does, what will happen? Well, we've told it to run this function, rotary change, which we've defined on line 11 here. And this does just the same as line 16, it just prints the values of DT pin and CLK pin. Line 15 is exactly the same, but just for CLK pin. In short, if a pin changes, we know about it, and it will tell us the values of both pins. Let's test our code out, so if we run, just printed the values of our pins at the start of the program, which shows both are high. So if we do one click on our Rotary Encoder, like with our LEDs, a lot has happened. Here's our results. Remember, each line prints the value of DT pin first and then CLK pin. There's a bit of a pattern, but there's also an unexpected repetition of 0, 0, which is strange, since theoretically we should only print the values of DT pin and CLK pin when they've changed, or when one of them's changed. So there shouldn't be any repetitions there, but there are. Maybe there's a bug or a problem with the implementation of MicroPython, or maybe the pins have in fact changed, but by the time we've printed them, they've already changed back. I'm not too concerned about it. I just want to get rid of the repeats, so let's do that. To filter the repeats, I'm going to start by making the value of DT pin and CLK pin into one 2-bit binary number. If you're not familiar with binary or any other number base, then we have a great video on number bases, such as binary and hex, and by the end of that video you'll be able to convert between any number base you want. Anyways, we'll want to view that 2-bit binary number in a variable, so I'm going to put it in a variable called last status. And the first value is of DT pin, so let's get the value of DT pin. This is the first digit, so if there's going to be another digit following it, then it needs to be shifted one place to the left to make room for that next digit. So to do this, we'll do a binary shift, and we'll shift it one place, and this is just going to move our digit one place to the left. Okay, we'll put that in brackets, and now we need to add the value of CLK pin, so I'll just do an OR and then the value of CLK pin. DT pin and CLK pin are two separate variables with only two possible values, either a 0 or a 1. Whatever those values are, we want to squish them together into one number, one 2-bit binary number, and we want to store that number in a variable called last value. And I've written out all the possibilities, and this column is going to be the value of DT pin, and this column is going to be the value of CLK pin. Now on its own, DT pin would be in this column, so we need to move it up a column, and we can do that by just doing a binary shift, and we'll just move it up one column, and then that would leave space to put in the value of CLK pin in this column. And we can do that very simply by just adding the value of CLK pin to our number, But since we're using binary operators, I just used an OR. I'm not going to go into detail and explain what ORs are or ANDs, because that's a separate video. But if you did want me to do that, then do let me know in the comment section down below. When we call our function rotary change, theoretically, the value of either DT pin or CLK pin must have changed, which means last status, our 2-bit binary number, must have changed. So we need to update last status, so I'm going to copy that. But then call it something else, so we're going to call it new status. Now we need to check if there's been any repetitions. So if our new status is equal to last status, then we're just going to return, which means we're just going to come out of our function rotary change, so we won't ever get to line 15, so we won't print the value of DT pin and CLK pin. But what if there's been no repetitions? Well, we need to update last status. So last status is now equal to new status. So this should filter out our repetitions. Now, if we run this, there's going to be a problem. Super briefly, the variable last status has been assigned outside of our function rotary change, so that variable doesn't exist inside of our function. We could say that's because last status isn't in its scope. To fix this, we can just go global last status. Now last status does exist inside of our function, and our problem is solved. Let's test it all out. So remember, these are our results from before, so we've got a few repetitions there. Let's run our program again. Okay, we'll do one click. Great, we filtered out all of our repetitions. It's worked. I've come from another language that uses camel case, but I've noticed a lot of Python users use underscores when they start a new word instead of using a capital letter, so I'm just going to change that in my code. So if we run our program again and adjust our rotary encoder clockwise, we get this pattern 1110000111. If we do it again, another click, we've got the same pattern repeated again. So if we stop the program, run it again, and this time let's adjust our rotary encoder anti-clockwise. So one click anti-clockwise. Okay, we've got a different pattern here. Let's do another click. Okay, we've got the same pattern repeated again. And so these results are great, very predictable. So hopefully if we can detect one of these two patterns, we'll be able to know whether our rotary encoder is going clockwise or anti-clockwise. I've written down the patterns for both a clockwise turn and anti-clockwise or counterclockwise turn on some sticky notes. And we're going to check for a transition from the first to the second value in one of these patterns to signify the start of a turn. For both clockwise and anti-clockwise, the first value will be last status and then the second value will be new status. So like with what we did with last status and new status, we're going to squash these two values together into one number and then store that number in a variable. That variable is going to be called transition. The first value is going to be of last status, which is a 2-bit number, so it needs to be shifted 2 places to the left using a binary shift again to make room for the value of new status, which is as well 2 bits. And now we're just going to add the value of new status by using an OR and then new status. So if our transition is equal to, for clockwise, the 4-bit binary number is going to be 1110. OB just means that it's a binary number and it's 1110. Or if transition is equal to 1101, then we just want to say something like our rotary encoder has started to turn. So let's give it a go. So running our program, if we start to turn it, there we go, it's told us our rotary encoder has started to turn, and the other direction, yeah, we've got the same thing. Really, we should detect all of these transitions here. However, let's see if we can just get away with detecting the first transition. So we'll do that and see how accurate we are. So I'm going to start by creating a variable here called val and give it a value of 0. And the plan is, when we adjust our rotary encoder 1 click clockwise, our value increases by 1, and 1 click anti-clockwise, val decreases by 1. So we're going to be using our variable val in rotary change, so we need to make sure that we can access it. So global last status, comma, val. All we want to print is the variable val, so let's just get rid of all these prints here. We'll just hash them out. That was a bit annoying there. Just make a space there. Okay, so the first thing we want to check is if we're adjusting it clockwise. So if transition is equal to 1110, so we'll just copy that here. Then our value is going to increase by 1, so val equals val plus 1. And then we're just going to print val. Now let's do the same, but if we're just going anti-clockwise, so it's going to be elif. And the first transition for anti-clockwise is 1, 1, and then 0, 1. So we'll change that. And then if we're going anti-clockwise, the value is going to decrease by 1, so it's going to be minus 1. Let's see how accurate our results are. So I'm going to run. Okay, so we're going clockwise, so we should increase by 1. So 1, 2, 3. Looking accurate so far. 4. I was moving quite fast and it's detecting every single click. Anti-clockwise, yep, we're decreasing by 1 every time. See if we go into minuses. Yep, this is looking really good, pretty accurate, and it's detecting every single click, and I'm going pretty fast. So let's do an experiment. So we're at 3. Let's just go. Half a turn is 10 clicks. So if we do half a turn, we should get to 21. So wow, yeah, that's very accurate. A full rotation is 20 clicks. So if we do a full rotation, let's go anti-clockwise, we should get to 1. So let's try that. So. Wow, yeah, I've not spotted any mistakes there. Great, so it works. Now I'm going to put all of this into a class just so that anyone can use my code without even knowing how it works, and just so it's easier for people to take my code and use it. So before we do that, I'm just going to delete everything that I've hashed out, including line 33 because we don't need that anymore. Okay, so now I'm going to go class, and then the name of my class, I'm going to go Rotary, capital R. And then everything underneath it needs to be indented, so I'm going to select it all, and then just indent it, so indent selected lines. Now I'm going to do an init, so I'm going to go def, and then underscore, underscore, init, underscore, underscore. And then I'm going to give it self because we're making a class. And what are we initializing? Well, it makes sense for them just to give me their DT pin and their CLK pin, and then they don't have to worry about anything else, and we do all that work for them, and they can just get on with whatever they're doing. They don't have to worry about it. Now we can just delete line 5 and 6 there. Underneath, I'm going to copy this line here, DT pin, and then put it under here. And then all I need to do now is just do self and then dot and then DT pin. And I can do the same thing for CLK pin. What's this self business? Well, because we're using a class, it's powerful. We can have multiple rotary encoders with just this one class. Let's say you had 2, one in one variable and one in another. Let's say Rotary Encoder 1 and Rotary Encoder 2. They're 2 separate instances but of the same class. This self means which one is it. When I say instance, that's what I mean. Rotary Encoder 1 and Rotary Encoder 2 do the same thing because they're the same class, but they'll have different DT pin and CLK pins. Also, instead of having those variables floating around like before, I'm attaching them to the specific instance. Incidentally, we didn't have to call self, we could have called it something else, but it's just less confusing if everybody calls it the same thing. Also, the person using the class doesn't have to pass self, it's automatic. They'll just pass the DT and CLK pin. We don't really know what the person using my class is going to use it for, so val is unnecessary, we can delete it. And if we really want it, we can just use it in our own code when we use this class. We don't need this global last status val anymore, so we can just delete that line. New status, we don't need to do self dot new status because in the end we're just getting rid of new status anyways. But we do need to do self dot dt pin dot value, and we also need to do self dot CLK pin dot value here. Here we should do self dot last status. Again, transition, we don't need to do self dot transition because we're getting rid of it anyways as well. But last status does need the self. And then here, we don't really need to print the value of val anymore, so we can just delete that. This is if we're adjusting our rotary encoder clockwise, so we can just do something like clockwise turn detected. And the same here, we don't need to do any of this. We'll just replace it with anti-clockwise or counterclockwise turn detected. Self.last status equals new status. I almost forgot on our function rotary change, we need to pass it self and then because we're doing a class, and then also pin. Okay, back to down here, we need to bring up these two lines to our constructor. And then all we need to do is self.dtpin and self.clkpin.irq, and then the handler is going to be self.rotaryChange, and then the same for clkpin. The handler is going to be self.rotaryChange again. We can get rid of this while loop, we don't need it anymore. And then I'm just going to quickly neaten up our code and then save it onto our device as rotary.py. I've opened a new file and I'm just going to go from Rotary, which is our file name here, which is this file here. I'm going to import our class Rotary, which has a capital R, which is the class we've just made. And then I'm also going to import uTime as well. It's time. Okay, now I'm just going to have a variable called Rotary, and I'm going to use our class we've just made called Rotary. And what did we pass it? Well, we just passed it two things. First thing is the DT pin, which in my case is GPIO pin 0, comma, and then the pin number of CLK pin, which in my case is 1. Okay, and then I'm just going to have an infinite loop so that our program never ends. And I'm just going to sleep for 0.1 seconds. Let's run it and see if it works. So let's just press run on our MicroPython device. Oh, I need to save it. Okay, let's give it one click. Clockwise turn detected. Let's go the other direction. Anti-clockwise turn detected. So I'm in our class Rotary, and I'm just going to give it a property in init called handlers. And this is just an empty list. And the plan is, the code that can use me sends me functions that it wants me to run when things happen. So I'm going to write a method to allow them to add a handler. So def add handler, and I'm going to go self, and then we're going to be able to pass it handler, which hopefully is the function that they want me to run. And then I'm going to go self.handlers.append, and append just means that I'm adding to something, and what am I adding? Well, I'm adding handler. So this is a very simple function, it just adds whatever handler is, hopefully it's a function, to our empty list handlers, which is here. I've written another simple function that just runs every handler, which should be a function, in our list of handlers and calls them all. And what does it pass them? Well, it passes them whatever type is. So now we're going to use call handlers. I think call handlers would make more sense. So instead of printing clockwise turn detected, I'm going to call handlers, so self.call handlers, and then I'm going to pass it 1. I'm going to do the same thing for anti-clockwise, but change that 1 to a 2. So I'm back in my simple code, and I'm just going to write my handler. So it's just going to be a function called Rotary Changed. And let's be able to pass it something. I'm just going to say change. Okay, and now I'm just going to print a little message with whatever it's passed me. Rotary changed, obviously it's not the best, but never mind. And then change, which is what we've passed it here. Now I'm just going to get my rotary, which is this here. I'm just going to call that new method we've just added that appends to my list of handlers. So that's add handler. And I'm just going to send it this function that we've just made here. Now let's see if it works. So we just need to make sure I've saved rotary.py. Run. Okay. 1 click clockwise. Brilliant. Rotary change and 1. Anti-clockwise, we should have 2. Yep. Brilliant. It works. That's a lot more useful and a lot simpler. And it's actually talking to us now, which is great. We're going to try and get our code back to how it was. So I'm going to start by creating a variable val, which just is 0. And then in our rotary changed function, we want to use val, so we'll do global val. Instead of printing this, we're just going to print val. Now, if our change is equal to 1, that in our case, that means that our rotary encoder is going clockwise, then our val wants to increase by 1, so we'll do val equals val plus 1. And if elif change is 2, so in our case, if it's 2, that means we're going anti-clockwise or counterclockwise, then val needs to decrease by 1, so val equals val minus 1. Now, of course, we're just printing val. Let's test this out to see if it works. So I'll run. Okay, so I'm going to do 1 click. 1, 2, 3. Brilliant. We're going clockwise. I'm moving quite fast and it seems to be working fine. Backwards, anti-clockwise, yep. I'm moving quite fast and it's detecting every single one. Perfect, yeah, so we're back how we were. A few niceties just to make this more robust. I'm back in our Rotary class here, and we're in an interrupt here, so we shouldn't be calling something that's going to be calling something that's going to be calling something, because it may take a long time. It could start modifying variables, like ones that aren't even in our class. So we don't want to be doing that in an interrupt request. We want the person using my class not to worry about anything. So I'm on line 21 here, and we can schedule this to run very soon, but not right this instant. So the way I'm going to do that is, if I go to the top here, we're going to import MicroPython, and then we can go back down here. And instead of this line here, I'm going to hash that out. We can do this, MicroPython dot schedule. Now we just need to give the function that we want to schedule, which is our function callHandlers. So we're going to go self.callHandlers. And then we just need to give it the argument, which is 1, because we're going clockwise. Okay, and then we'll do the same thing if our rotary encoder is going anti-clockwise, so same thing here. But the argument is 2, because we're going anti-clockwise. And then of course we can just delete this line here, because we're not using it anymore. We're replacing it with a schedule. So this will just wait until it's sort of safe to run our function here. I'm going to create some class variables here that belong to Rotary. And I've not put these in our init because every time we don't need to create an instance, so I'll just put them outside here. And all of these are just equal to a value each. And this is just so that it's easier for us to read and easier to work with. Let's take, for example, pin.in. If we go into REPL here, I'll just need to import a few things. Let's just do pin.in, which is setting our pin as an input pin. See, that's just a value. Pin.out. Again, another value again. We've got pin.falling. Again, just another value. Pin.rising. Another value again. So they're just easier for us to work with, really. So that's why I've got that here. Now I'm just going to go through and replace some of our values. So here we can replace 1 for clockwise with rot_CW for clockwise. Rot_CCW for counterclockwise is equal to 2. So we can go and replace this 2 here. And because these are both class variables, we need to put rotary dot and then our class variable. Do the same here. Okay, back into our simple code. Now we can replace our 1 and our 2 with the class variables we just made. Clockwise, CW. 2 is anti-clockwise or counterclockwise. Now let's get our switch pin working. Remember earlier, the switch pin was connected to that green LED, so when we pressed our rotary encoder down, the green LED lit up. So we need to connect our switch pin, which is there, to a pin on our Raspberry Pi Pico, so I'll do that now. Now we've connected up our switch pin, in our class we need to set it up. So we can pass the pin number of the DT pin first, then CLK pin, and now we need the switch pin, so I'll do SW. And to set up the switch pin we can do the same as with DT and CLK pin, but just call it something different like switch pin, SW pin, and pass it SW. Now, like with CLK and DT pin, we need to do an interrupt request, but with SW pin instead. But the handler, which is going to be the function that we're going to run when the interrupt request is called, is going to be a different function, so I'm just going to say switch detect. But we actually need to write this function, because I've not written it yet, so let's do that now. Create a new function called, what did we say, switch detect. And then we're going to pass it self and then pin, like we did with rotary change. I'm going to go if self.sw pin, our switch pin dot value. So this is the value of our switch pin. Our value of our switch pin is either going to be a 1 or a 0. In Python, 1 means true and a 0 means false. So if the value is 1, that will be if true, and we can carry on with our if statement. And if it's false, it just won't do our if statement. So we're going to do the same thing that we did here. So we're just scheduling call handlers, and then the argument is going to be SW press. So that means our switch is pressed. Else, well, this means that our switch has been released. So we'll just copy this line. Our switch hasn't been pressed, it's been released. And back in our simple code, and let's actually set up our switch pin. Here we can pass rotary our DT pin first our CLK pin, and now we can pass our switch pin, which for me is GPIO pin 2, so I'll do 2. And now we want something to happen when we press our switch. So I'm going to go here in our function rotary changed, and I'm going to go elif change is equal to, but we're checking whether our switch has been pressed. So our class variable is going to be sw_press for switch pressed. And what do we want to do if our switch has been pressed? We're just going to print something, just press. We're going to do the same thing, but if our switch has been released. So I'm going to copy this, paste it. Let me just get rid of this indent. I just need to clean something up here. Our program's not going to work if we print val here, and we'll print val if our rotary encoder goes counterclockwise or anti-clockwise, and we'll also print val if our rotary encoder goes clockwise. Now let's run this and see if it works. So I'll go run, and we'll press our rotary encoder, our switch, press, release, press, release. So it looks like we've got things the wrong way around. When we press it, it says release, and when we release it, it says press. Oh, I think I know what the problem is. So if we go into our rotary class, if we go to our switch detect function, I'm saying if our pin is high, then it's been pressed, but actually our pin is always going to be high, so that means that it's actually been released. So these are just the wrong way around. Okay, so I've swapped them around, so when it's high it's released, and when our pin is low, then that means it's been pressed, which should work now. So now let's give this another go. So let's just run. I'm going to press our switch, press, release, press, release. Okay, it works. Also, it's got a few repetitions, these are just bounce backs, but we can fix that. Instead of trying to debounce the switch, I'm just going to try to get rid of the repercussions. So in it, I'm just going to go self.lastButtonState, and that is going to be equal to the current value of the switch pin. And then when we call our function switch detect, that switch pin should have changed. So if our last button state is equal to the value of our switch pin, then that means there's been a repetition. So we're just going to return and come out of the switch detect. But if the switch button actually has changed, then we're going to set the last button state to that new value of the switch pin. So that should get rid of the repercussions. So we'll just test it out. Press release, press release. Yeah, it's looking like it's working. Cool. That's all for now. I really hope you found this video useful and you picked up a thing or two about rotary coders or something else. The code's on GitHub, link should be in description, and have a good day.
Well done, and thank you for sticking around to the end of this video. We really hope you enjoyed it and learned something new. If you did, please give it a big thumbs up and subscribe to our YouTube channel. Have a good day. Bye!